Hello and welcome to Study Guide Review. Now I'm going to jump right into the first page and I'm going to tell you that there are probably 10 questions that have to do with all of the stuff that's here. So focus on this stuff, know it well. Now the first one asks us to draw a model of the carbon atom. So the carbon atom, well, it says anything 2 through 12, but I'm going to pick carbon because it is right in the middle of things. So carbon. Now we have the center of the atom, and then we have the outer shell of the atom. Okay, so these are my different spots here. So I'm going to draw the protons. Now, I'm going to start with protons because protons are the most fundamental piece of the picture here, right? The entire periodic table is based on the proton. It's ordered on the basis of the proton. So there's 1, 2, 3, 4, 5, and 6 protons altogether. So protons are positively charged. So my little key here says that the positives are protons, okay? What about the other guy that lives in the center of the atom? Well, the center of the atom also has the neutrons. And I'm going to put an N here. 1, 2, 3, 4, 5, 6. And you can't really see my N's that well, but you get the idea. There's 6 neutrons in the nucleus as well, okay? So these two things combined give the carbon atom mass. Now, and if you look at most periodic tables, you'll see that there's this little mass number down here, 12. It's actually 12.01 in the case of carbon. That's because protons and neutrons give the atom its mass. They're by far the most massive thing in the atom. So I'm going to put that. Note. Protons and neutrons give atom mass. Another good thing to know, let me just scoot over a little bit. Another good thing to know is that the mass is counted by the mass number, and it equals protons plus neutrons. Okay. That leaves me with the last thing that we have here, which is the electrons. Now, in a perfectly balanced carbon atom, everything is going to be equal. The protons will have to balance out the electrons. So electrons I'm putting out here. There's 2 in the inner shell and then 4 in the outer shell. Remember, the inner shell always has 2, and then the outer shells always want to get to 8. I'm putting a little minus symbol next to each one of these because, yep, you guessed it, they are negatively charged. Can you see that okay? Here, let me turn the light on. There we go. Electrons. Okay, electrons are in the outer shell. And a note is that they have almost no mass. I'm going to put almost. It's very small. It's like teeny tiny. It's like 0.0000001, one of those kinds of numbers. It's negligible in comparison. So what we say about the electron is that essentially it doesn't have mass. All right. So I've labeled mass or no mass, labeled the charge, right? Electrons are negative, protons are positive, neutrons are neutral. The charge, the number, location of valence electrons. That's the last thing. Now, just like your hands and your feet interact with the outside world, the outermost particles are going to interact with other atoms and to create bonds and things like that. So when we've drawn Lewis structures, we're always talking about the outer electrons, the valence electrons. So that's the last piece to this puzzle. Star equals valence electrons. Okay. So now we're going to utilize all of this information to solve the next few questions. Okay. So first one is how many protons, neutrons, and electrons are in sulfur? So protons, sulfur is here. It's number 16. So we can see the atomic number is 16. So protons are 16. I'd always start with protons. Neutrons, if it's a balanced atom, it would also be 16. And you're thinking, Dilla, how do I know that it's balanced? Well, if it wasn't balanced, it would have a number like S21, or it would have a symbol that looked like S21, like this. Okay, this number, remember, is the mass number. Okay, this number is the mass number. So it tells you the combination of protons and neutrons, how many of those exist in the atom altogether. Anyways, neutrons, 16. Electrons in S minus, will, if it's balanced, then sulfur will also have 16 electrons, but there's a little minus symbol. And because electrons are negatively charged, we know that that little minus symbol means there's one more electron than there are protons. So the electrons, there must be one extra, so that would be 17. Okay. Let's move on to number 3. How many protons, neutrons, and electrons are in an uncharged atom of C2+? Now, first of all, I shouldn't say uncharged because it very clearly has a 2+ charge. I went back and added that 2+ later, and I forgot to take out this word. But that should not be there. So if you were confused, yeah, there was a reason you're confused when you did that. So calcium is element number 20. So same process, protons 20, neutrons 20, electrons, this time we have a 2+ charge. So that means we have 2 more protons than we do electrons, right? Because protons are positively charged. So since there are 20 protons, that must mean we have 18 electrons. Okay. Number 4, atom contains 55 protons. What is the element symbol? Well, that would be simply number 55, element 55, which is Cs, cesium, which incidentally is one of the 2 most reactive elements in the periodic table, but we'll get to that later. Number 5, an uncharged atom contains 31 electrons. How many protons does it have? Well, if it's uncharged, then the key to that is knowing that the protons and electrons have to be the same. So we don't even have to know what element it is. 31 is gallium, which is an interesting element. It's a metal that will melt in your hand if you hold it there long enough. It has about the same melting temperature as chocolate. But if it has 31 electrons, it must also have 31 protons. How many neutrons are in an atom of Hg2O1? Well, element Hg is, you'd have to find it on the periodic table, and here it is, Hg. It's mercury. So since we know the protons have to be 80, but what does that tell us about the neutrons? Well, remember, this is the mass number. Like I pointed out here, this number is the mass number. So that gives us protons plus neutrons. So 201 equals protons plus neutrons. But I already know that Hg, from finding it on the periodic table, the number of protons must be 80. So 201 equals 80 plus the number of neutrons. Now I have a totally solvable equation here. And essentially what you do is subtract 80 from both sides. So 201 minus 80 would give you 121. So the number of neutrons we have is 121. That would be your answer for 6. What about an isotope? So isotope is one of the first abnormal particles we talked about. And I will tell you now, Hg201 is an isotope, and this S21 is an isotope. So an isotope it's an atom with I'm going to put atoms with the same number of protons, but different numbers of, remember, it's the mass number, everything that's in the nucleus that has mass, protons and neutrons, different numbers of neutrons. That's what's changing. And what effect does that have on the atom itself? Well, the atom itself isn't going to change too much. It will become heavier because neutrons have mass, but it won't affect the charge or anything like that, okay? All right, so record the group number of each element and list whether it is a metal, nonmetal, or metalloid. So what I'm going to say about that is that we have this line here, the stair step, okay? Am I doing this right? So the metalloids are on the stair step. Metalloids being boron, silicon, germanium, astatine, antimony, tellurium, and last but not least, polonium. Okay, that's the stair step. These are all metalloids. So you can totally use your labeled periodic table in the test, but otherwise you would just have to know these are metalloids and that everything on this side of the periodic table would be a nonmetal plus hydrogen. And then everything else is going to be metals. Metals make up the majority of the materials that exist. So now it's just a matter of locating these things and labeling them. Also, the group numbers are vertical, right? So I'm just going to read these numbers off and that's going to tell us. So AS is astatine. It's in group 15 and it is a metalloid. Okay, potassium over here, group 1. Okay, it is a metal. Fluoride is over here in group 17, and it is a non-metal. Boron, right here, group 13, non-metal. Silicone, group 14, also, metalloid. Wait, what did I just say about boron? Boron is a metalloid. Let's change that. And then finally, calcium is in group 2, and that is a metal. Okay. All right, we'll pick it back up in the next video.